We're on page 3 now, exercise 14, and this is another FOIL multiply out. So if we do root 2w times root 2w, I can make that root 4w squared. And root 2w times root 7p, it's positive times positive. That's why we have the plus sign. Why don't I make that 2 times 7 is 14, and w times p is w times p. Can't write anything different. Then minus 7p times, minus root 7p times root 2w, that makes minus 7 times 2, 14. And p times w, or w times p, same thing. And last multiplication step, minus times plus makes minus, and it's root 49 p squared. Now we do the cleanup step. And square root of 4w squared is 2w. These are exact like radicals, square root 14wp, square root 14wp, plus one of them minus one of them means they cancel. And then we have minus, square root of 49 is 7, and square root of p squared is p. Now, it should be said also that whenever we have the square root of something times itself, what's the definition of square root? It's the thing that times itself gives you whatever is underneath that radical sign. So when we do this times this in the future, when we do the same radical times itself with a square root, not cube root or some other higher index, but a square root times the square root of the same thing is going to come out to be whatever the radicand is. So you saw that happen here twice. That's a time saver. You can still write this out like that if you like, but save time if you know that. What I just said. 15, if we brute force this, and by that just go crashing in there and multiply 48 times 72 and put it under one radical, that might work out, but it's going to give us a large number to have to deal with. On the other hand, if I factor a little bit first, let me zoom in just a tad. See, 48, if you divide by 2, you get 24, not a perfect square. But if you divide by 3, you get 16, which is a perfect square. So if I take that square root 48 and do this, I'm on my way to simplifying things the easy way. I'm just going to copy that 3. If I try to break down the square root of 72, divide that by 2, you get 36, another friendly little perfect square value. Okay, so now I can change this, keep that, change this, keep that. This becomes a 4. That's taken care of. Well, let me copy the 3. That's taken care of. This becomes a 6. And what is still under the radical sign? The 3 and the 2. So I'll say times the square root of 3 times 2 makes a 6. And 4 times 3 times 6 can be multiplied out. 4 times 3 is 12. And 12 times 6 is 72. So this whole big expression is equivalent exactly to that. We've made the radicand as small as possible. So we're done. Okay. Moving on to the next section, we have this new vocabulary word to learn, the conjugates. Here's a pair of conjugates. 3 minus root 7 has the conjugate 3 plus root 7. So what's the difference between these two expressions? The sign in the middle. The conjugate of this would be that. 3 plus root 7 would be 3 minus root 7. And you notice back here, weren't we multiplying conjugates back here? Root 2w minus root 7p, root 2w plus root 7p. And notice what happened, sort of special, in the end, we got no middle term, so to speak, and we got the square of the first term minus the square of the second term. Now, not to overwhelm you or make your head explode, but remember this little factoring pattern. If we have two things added times the same two things subtracted, what do we get? The square of the first thing minus the square of the second thing. We were using this idea of conjugates back then when we had this difference of squares factoring pattern. So, are these conjugates? Yes, it's the same two expressions. One of them subtracted, the other one's added. So after we multiply this out, thinking this way, we should get the square of 8 take away the square of the square root of 11. The square of 8 take away the square of the square root of 11. The square of the square root of 11 is just 11. So the answer should turn out to be, what is that, 64 take away 11, that's 53. So we'll see. Put question marks. This is a mystery. Let's see, does it really happen? We'll do it the old-fashioned way, FOIL it out. 8 times 8, 64. Then 8 times root 11, that's plus 8 root 11. Done with the 8. Minus root 11 times 8, that's minus 8 root 11. And finally, minus root 11 times plus root 11, that's minus square root of 121. I could have just said minus 11, but too late, I already wrote that. So we have 64. There are like radicals with opposite coefficients. They disappear, they're canceled. Minus square root of 121 is 11. So final answer is 53. Okay? So now that we've done that, we sort of earn the right to use the idea of conjugates. Do we have conjugates here? That's square root 7, square root 3. One says plus, one says minus. Feel free to do the FOIL thing, but the answer is going to be just the square of the first thing minus the square of the second thing. By first thing and second thing, I mean in the order they're written, because, you know, with subtraction, the order matters. So, what's the square of the square root of 7? 7. What's the square of the square root of 3? 3. 7 minus 3. See, I didn't even need a calculator. Be careful down here. These are a little sneaky. Nothing too bad, but do we have conjugates? Those are the same. Those are the same. One says add, the other says subtract. So it'll turn out to be the square of the first thing minus the square of the second thing. The square of 5, I took the liberty to immediately write 25. The square of the square root of 5 is 5. 25, take away 5, final answer will be 20. Okay? And just to show you that I'm not lying, you know how teachers are. If I type this in just the way you see it, 5 plus square root 5 times 5 minus square root 5. There you go. And you could do the same thing with any of them. Well, maybe you want to hit pause for a second and try this and then come back and see if we agree. I'm going to use the idea that I'm multiplying conjugates. Here's the square root of 8 in both and 1 in both. One says plus, the other says minus. So the square of the square root of 8 minus the square of the ordinary number 1. This should be our answer. Square of the square root of 8 is 8. Square of 1 is 1. 8 take away 1, 7. And that's the end of page 3. See you in a few minutes with page 4.